I'm Clay Mackel, for those of you who don't know me. These under the hood sessions, especially this one's going to be a bit more technical. The one I did 2 years ago it had more of like the history of FileMaker and some of the database engine, and I went through some of like the opening process, things that you could actually probably more useful for actually doing development and stuff like this. A lot of this talk here is going to be some stuff that it may just be more interesting as opposed to explicitly usable by you. I've been working at Apple since '86, which then turned into Claris and which turned into FileMaker. I've been working on FileMaker itself since around '89. Did the initial Windows port of FileMaker, did the first version of Server, did the first version of Instant Web Publishing, worked on the Draco engine with John Thatcher and Sean Flowsky. Helped Chris out on the initial Go version, iOS Go. We did a big transition from Carbon to Cocoa on the Mac side, so I was doing a lot of the work to do that. And that was like a 4-year process. So on the Macintosh now, we are a pure Cocoa application now. On the Windows side, unfortunately, there's still large portions of it that's a MFC, which is the Microsoft Foundation classes. We're moving to the Windows Presentation Foundation, to a more modern API on the Windows side. And this is going to be basically a 4-year process to go through that. So you've been seeing some of the changes as we've gone from a MDI to SDI Windows. I'm not personally working on that portion, but I just wanted to mention that it's a process to move over until we can start using all of WPF and all the new features that Windows is offering and stuff like that. But that is in progress. We're about maybe a third or a halfway through that process right now. And most recently, and I have a session tomorrow about this on the data migration tool. I didn't do the initial work on it, but I did finish it and ended up pretty much rewriting it completely. But yeah, the initial design, they thought they had to work in a 32-bit machine, and we changed the requirement saying you have to have a 64-bit machine to run the tool. So that you can speed things up if you can assume that you have that much memory to work with. They were trying to be able to survive in a small memory environment, and we said, no, if you can use the tool, you need a big machine. So this topic was originally done in 2006, though I did notice that I had an hour and a half back then, and now I only have an hour. This is the slide from that actual deck. Rearranged the talk a little bit, and that's Christopher Krim. We always had big events at FileMaker for Halloween. So back in 2006, this was what the component architecture of a server product was working. You'll notice that over on the server side, the FileMaker Server had the XDBC processing built in. It actually ran the scripts inside the same process. The Draco engine is kind of in red. I mean, it was around back then. This is about the Pro 8.5 timeframe for if you're looking at product versions. FileMaker had a mobile product. This is not the iOS product. This is FileMaker Mobile, which ran on Palm devices and WinCE devices. We actually had a version for the Newton also, which we never shipped. I used it. It was kind of nice. The problem is the Newton was really only useful once you got to the 2000, the Newton 2000. The earlier ones were really just... The web publishing core, back then it was IWP. This is when we were still doing kind of the Web 1.0 technologies before we moved to WebDirect, which is using the new modern techniques. So 2 years later, 2 years ago, I showed this slide in my talk 2 years ago. So this is how the architecture moved to at that point. We're using a lot more Tomcat with Java inside there. We had the standby server. We were using the UAC, which was using Vaadin to do the administration stuff on the server. But things have changed in 2 years. We're slowly transitioning away from using Java and Tomcat as major component tools for behind the web server. We're moving over to JavaScript and Node.js. And that's going to be pretty much, if you see this in future and like where the new stuff is, it's pretty much all going to be Node.js. You'll see C++ processes at the bottom, Node.js, JavaScript in the middle, and then the web server on the top. Well, stuff that we talked about Monday night is going to be replacing some of these items that are up here too. And there's going to be new things showing up in here. You know, the UAC is gone now, the FAC, we're using all the admin APIs, and things have changed quite a bit now, and then probably in 2 years, the slide is going to look pretty drastically different again at that point. So now go into indexing. Last time I did this talk, I started with doing queries and stuff like that, but I realized that the indexing is one of the key parts of FileMaker, and one of the things that makes it quick when it's doing queries and stuff like that. We're going to be talking about different components of this part of the UI. So how many people have actually manipulated or make changes in this part of the UI? Okay, I don't know whether some people even go down and find this thing, but I guess this is an advanced topic, so I guess you've eventually found this area. Because it's buried pretty deep down in the different panels when you get into the field definitions. You have to, under the field options, and you have to hit the storage tab. First, what is an index? It's very much like in a book. When you open up a book and at the end you see a bunch of words and you see which page number things are on. Logically, that's the same thing that's going on inside FileMaker. It's used for queries and joins, and when I'm talking about queries, that's really more like find mode. When you do perform find in the scripting engine. The joins are things that happen if you're using the join graph or the relational graph that's in the UI. I'm sometimes using the internal terminology versus the terminology that's in the UI, but that's the mapping. If you hear me say join, you kind of think like portals. If I say query, think about find mode. It's also used for unique and existing validation. Basically, you have to have an index for those features to work. It's used for value lists, auto-completion, for value, not custom value lists, but value lists based on fields or value lists based on a relationship. And also the rawest form of being able to see the index is basically the insert from index dialog box. I keep trying to cut that feature because it's really a pain to implement to have a UI display the entire index raw basically like that, but I keep getting pushback from people when I try to get rid of that feature. It kind of really does a raw walk of the index, and then it's using index entries to search back into the fields to find text that matches the index entries. Now this index tends to be created automatically whenever you do any of these operations. So if you just have a regular file and you don't change any of these options, FileMaker will create the index for you automatically. You don't even have to know about it. That's why I kind of asked whether you've ever seen this dialog box. But that one thing I have circled up in red does change that behavior. You can stop FileMaker, you can force FileMaker never to create an index on a particular field. Now that means when you do that unique existing validation, value lists, the insert from index is not going to work. Joins won't work. Find mode will continue working even if you force it not to have an index. We'll fall back and start doing hard scans across the data. Basically look at all the rows, look at each one to find a match to display. So you can work without indexes for doing find operations. The other way to create indexes is coming from the XDBC world, in ODBC world. You can go through, you tell it to drop an index, create an index. That's the one other place where you can control this stuff. Now in this dialog, so we'll talk about these three radio buttons that you have up there. So you have three choices. There's actually, for a particular field, there's actually multiple indexes that are stored underneath there. We have a word index where if you're looking as if in a book, if you looked at the back of it, each individual word would have the list of pages everywhere where that word exists. So something like the would have almost like every page listed on it. And that's the same in FileMaker. That index, if you have just general text, the word will have pretty much every record listed in it if you have text fields that just have general text, like legal briefs or something like that in it. The other index is called the value index. The value index is based off of carriage returns, or paragraph separators, whatever the paragraph separator is. Internally, FileMaker has always used carriage return character as the paragraph separator because the history goes back to the old Mac OS time frame, and that was a separator. On Microsoft products, they used line feed and carriage return. Unix machines uses line feed instead, but we tried to normalize everything inside as carriage return. Though the text engine and the calc engine and all that stuff will treat those as line separators too, whichever set of characters it sees. That does become a little bit more important when you're dealing with JSON because some services don't want specific line feed terminators depending on what service you're talking to. And then it's even more complex than that. There's not just necessarily both the word and the value index. For Japanese, we have relaxed indexes. So you could conceivably, for a Japanese field, have 4 different indexes in there. A relaxed word one, relaxed value, a regular word, and regular value. And that's to help with the Japanese style queries that go on inside the product. Words tend to be separated by spaces, talk to the paragraphs. Repetitions, when you have a repeating field, all the repetitions are considered to be in the same record. So it'll grab, when the indexing code is working, it'll grab all the text from the first repetition, add that to the index, for that particular record number. Then I'll go to the next repetition, look at that, add that, all pointing to the same record. Everything will get indexed, and all of it. It basically treats that all the repetitions are really just one field, is what's going on in there. Now we get down into we're kind of getting even smaller now. Now we're dealing with the individual words when we're talking about text indexing. The language actually changes the behavior of the type of index that we're creating. That has a big effect on the size and stuff like that, because around here we're probably usually mainly using English. You'll notice that there's a Unicode choice at the bottom, which basically treats every character as completely independent. The case is different. If you need to do case-sensitive searches or case-sensitive queries or joins, you can switch to the Unicode quote language. When we're processing characters, whether it's a word index or a value index, it's the same. And then you'll see this guideline that we index the first 100 characters of any word or any value. And that's all that's put in the index. The index entries and pretty much everything inside FileMaker is stored in this tree format that has been described in other places. And I think I have a little chart later on showing it. But the key value, kind of like in JSON where you have keys and values and stuff like that, our keys inside FileMaker in the raw low file format is limited to 255 bytes. Which works out to be roughly about, it's usable for 100 characters, because in this German example, if you go through and switch the default language to German, whenever there's a with an umlaut over it, that actually gets indexed as A and E separately, because that's how their sorting rules work and how their telephone searching rules work. Actually, there's multiple German entries for depending what style of German sorting you want to do, and all the different languages in this pop-up slightly change the different of how characters expand or not. So actually, if I just typed a whole bunch of A with umlauts in there, actually you're only going to be able to have 50 characters basically at that point, because it really expanded it out to 100 each. Technically, you could probably get in 110 or 115 normally, but round it to 100 and say on average it's 100. From some of the stats we've done looking at indexes that we've gotten from people and stuff like that, I feel pretty confident that 100 works is a good round number to deal with. Number, dates, times, and timestamped indexes don't have the choice of minimum in the middle there, because there is only one type of index. When I said there's multiple index types, I really should have also mentioned that that's only for text fields, that you'll have up to 4 for Japanese. For number fields, timestamp fields, and stuff like that, there is only one type of index. You only get the choice of none or all in that case. For text, I'm kind of talking about, each character ends up eating up 2 bytes, it gets larger as we're indexing. Numbers work the opposite way. Each digit gets squashed down to 4 bits, which is kind of called a nibble if you're getting into technical. We have bits, nibbles, and then bytes. If you're talking about different sizes of the number, the size of a structure in memory. One reason that we do this is that we don't use any of the IEEE standards and other number standards for how we store numbers, because we have this 400-digit significance. We can tell the difference between 14 billion and 1 and 14 billion and 2. I mean, if you try to do that in Excel, it's going to just tell you it's the same number because it only has 15 digits of significance. But FileMaker has basically 400 digits of significance with its numbers. So to keep our indexes unique for all these significant characters, we store each digit as a nibble, as 4 bits. Now, we don't store all 200 bytes for it. We only store the portions that's non-zero, basically. So the indexes can actually be pretty small. So a 1-digit number will only eat up 1 nibble, but you still have to have a minimum of 1 byte. So that's why number indexes tend to be a lot smaller than text indexes. And this discussion comes up quite often as you watch these interesting arguments on the forums about whether numbers or text is better as primary keys. But this is the main description of why you guys are having this discussion. Or records that have containers and summary fields, those are never indexed at this point. Though that has been a feature that's on a feature list that keeps bubbling up and down, and it hasn't made it over the line to be done yet. But we have done some prototypes of indexing the contents of PDFs and metadata that we can find in images and stuff like that to be able to do a query in a container field. We probably will never allow joins on it, but okay, so at least one person wants this feature, but it has been considered, and some prototypes have been done, but it's one of those things that never get over the line of, okay, we are going to put it in this release. So we talk about queries a little bit more. So when you're in find mode, you're creating all these different requests, and you could almost have a whole talk on what you can do in find mode and how that actually works, because it's very different than a lot of other query languages that you work with, because each row that's in your find request, or each record that's in it, depending on whether you're in list view or browse in record mode, each row is an individual request, and every query that you put in each field is a logical AND operator. So if you put Clay in first name and Mackwell in the last name field, it has to have both Clay in the first and Mackwell in the last name to find that. If you make a new request, a second request that's underneath it, those are a logical OR operated with all the results of the previous operations. So you can then search for Mary Jane or something like that, and then you'll see both Clay Mackwell and Mary Jane if you do that query with the two requests. The omit flag reverses the operation and will remove those found results from the previous results. So you have to think of, when we're doing queries, that you really have to think of it as we're walking down the request. We're starting at request 1, then request 2. We're adding records from requests that don't say omit, and then removing records that say the omit on it. And that doesn't really map into OR and AND languages like in SQL very directly and stuff like that. But you can do some interesting things that you can't do in those other languages too. That's even extended with the extend finds and the constrain finds too. It works on a current found set, and you can add records to it and remove stuff to it. But that's the first part of the processing, just to start going down in there. When FileMaker starts looking at this stuff, it has to determine which hosts that it needs to talk to. Because you can put files on multiple hosts. You can have your UI file on one and maybe the data file on a different host. I don't know how often people do this, but we do support that. And so it has to figure out, and you can actually have a file locally too. So it may have to look in files in multiple hosts and on locally. So the first part of the query is to analyze all the different locations that need to be, the find operations and where the indexes are located, and who the client is going to have to talk to do the query. And then to determine which queries actually have to be done on the client is a little bit more complex too, because even though there's indexes and data that's over server and the query could be done there, if you're doing a query on an unstored calc that depends on a function that has local state information that only the client knows about and not the server, the query engine has to be told, oh, don't send that request over to the server. I actually have to do that locally. So there's the first part of the find is doing all this analysis, figuring this out. And I'm going to point to a knowledge base article called How Functions Evaluate Different on the Host versus the Client at the end. And it describes which functions can be done on the host and which ones can't. And that basically determines whether that query can be done on the host or it has to be done on the client. And then once it knows this plan, it knows every places that the query needs to be executed and where it can be executed, then it has to parse, split the query up, send the query to the different hosts, do the operations locally, and then merge all these results back together again. Now when you have a related field, I'm going to go more into joins on the next page, but when you're doing a search in a related field, it does the standard join process I'm going to talk later. But there's an addition to it, is that it does like what you would think in a portal. If you type something in the field, it goes off, it starts doing the expansion and saying, oh, this record is related to these 4 records, and then each of those 4 records are related to 2 records each. So now you have 8 records in your third table away and stuff like that. Once it gets that result, it then, since you're doing the query from the first table, you want to find all the records that would ever display information like that from the table that's 3 away. So it has to do the reverse join. So then it goes through for all those records that it found in the destination table. Then it'll start doing joins and queries going backwards again to find all the rows that would match all the ones that were found in the table that was like 3 or 4 away, however it was. This can take a little bit of a while to do, and this is why queries like this won't work unless you have both the field indexed in the source and the destination of the relationship. Now you can do just pure joins for portals and stuff like that with a global field or an unstored field on the, quote, the left side, if you think about it that way, but from the source, and then it has to be indexed on the far point. But for doing queries, the reason it has to be indexed on both sides is so it can do this reverse find to find all the records that would ever show the records that it actually found in the table that's far away. And then after all this processing is done, it's gone to all the different hosts, it's done local ones, it's merged all the results back together again. Then it has to apply any security restrictions on it too. In managed security, you can go through and you can specify calculations to say whether this record is visible to the current user and go through and generate that. In the worst case, you'll have to go through the results at the list of records that it got back and then evaluate that calculation for each of those rows. But there's some optimizations that have been put in some years ago where if you can turn that calculation function into a query, it'll actually use the index and say, oh, you want the field has to equal Bob or something like that for you to be able to see it. And it'll go through and actually do a query for Bob instead of going through and scanning all the records looking for Bob. Now, I'm talking about how all these result sets are moving around and coming back and forth. Something that's inside FileMaker, in SQL databases usually have these temporary tables that are moving around, or these tables that have been created from results. What FileMaker is moving around is sparse bitmaps. So when I'm talking about a found set or a result set, I'm talking about, it's really just a series of bits. So one bit, which there's 4 in a nibble, there's 8 bits in a byte, it represents one record. And then there's, but it's not one large bitmap, it's a sparse bitmap. They'll have big gaps in the middle if there's large sections where there aren't any characters. So these record lists are pretty compact, and this is what's moving around in this whole system when I'm saying that we split queries off to be done on each host. The results of all these queries coming back from everyone are basically these little sparse bitmaps. So if the results of a query or a partial query is like only 3 records, it's only 3 bits, and the answer actually comes back as only like 1 byte over the network. Well, there's more overhead around it, but the payload is actually only 1 byte in size. And joins are kind of is a more specialized query. Talked about the relational references. Talked about how it does the different hops across. So it'll do the A, find the ones in B's, and then look at all the results of B's and look those all up into the C's. These queries are usually mostly independent. When you have a relationship defined in the join graph, they're pretty much all independent from any. The same relationship will be used whether it's part of a validation, part of a portal, part of any other operator inside of the calc in some type of field. The one little difference is that the sorts defined on a portal is a separate filter that's done at the end of this entire processing. So the portal actually is managing the sort if you're doing sorts there. Now, if you're doing sorts inside the relationship, then that's kind of part of the entire process, and that sort will be the same for everything else. So this is why you run into some of these cases if you're trying to do summaries based on sorts or views, and you're using the calc engine on one side versus the portal. The calc engine doesn't know about portal sorts, the sorts that are done by portals. The calculation engine only knows about the sorts that are part of the actual relational schema. We tried to figure out ways to work around that, and that really turned to be much of a pretty big issue. We'd actually have to probably add a new calc function where you specify like the name of the portal to be able to get the actual which results that you want that's on the layout at that point, because calcs are executed in a bunch of different states and it doesn't necessarily even know what's on the screen at that moment. Now the big thing with the joins that's different from the queries is that we cache those results. And it's every intermediate result too. When we did the query from A to B, we remembered, well, for record 3, it's related to record table by having these 4 rows in record B. So we remember that. And then we use that result. We'll say, oh, when we go from B to C, we'll go through and we'll make one for those 3 records. We'll cache the results for those 3 records from B to C. Now, if you had like a table E that it went from A to B to E, we'll reuse the cached result from A to B that we generated before because that's the same going through the path. So as you're walking through the path, we're saving each intermediate result as a list of records. We go through, and the UI code tries to go through and flush these cache items when it sees that, oh, the matching field between A and B changed, so okay, that means your results are different, so we have to flush them. But there's some cases where we can't detect that. That's a case where we've been adding a couple more script steps recently. But we've always had the one for when you refresh window to dump all join results for the current record, and then recently we've had one where you can dump the join results for a particular object. Yeah, so you can get more finer control over the dumping of these results, because the caching of these results is what keeps the portal performance up and stuff like that, so we don't have to keep going over the network and doing the joins over and over again. And I guess I've said this before, I don't really have time to go into all the details of how SQL works, but all this stuff I'm talking about, we're not a SQL database engine. We're not doing things. This Draco engine really is its own beast. It's a relational engine, but it's not necessarily the typical SQL design. The big part is SQL, you do basically ad hoc queries. You can do a query at any point. FileMaker some of its advantages and disadvantages is that we force you to define the schema up front with the join graph. And there's advantages to that and disadvantages to that, but that's the design we went with. When FileMaker is acting as an SQL client, that's the ESS feature. What we're doing there is we're basically kind of converting our Draco syntax, this query process that I just described to you. We go through that and we're saying, oh, okay, we have to talk to these tables that look like FileMaker tables, and we have to generate SQL to match a query that would, there's this logic in there that tries to map the FileMaker, the requests, the requests, that each row request, and the omit statements. And that gets a little tricky trying to map that into actual SQL statements. Doing portal finds, portals are pretty simple because those are usually just straight less than, greater than, equal joins. So portals are easy to do with ESS. It's what I'm calling queries is the hard part to do the translation for. And then sometimes we can't do much and we end up getting more records. We try to minimize the amount of records we get back from the SQL database, and then we'll have to do a hard filter ourselves and just do the same type filtering as if all the contents were an unstored calculation. And that's the worst case. If we can't map it at all, we may pull the entire table over from the ESS source and then scan everything locally in the client. But usually, well, I could probably derive a case that did that, but it doesn't come up very often. And then the opposite side, where FileMaker is acting as a data source, that's a different process, because there we're having SQL coming in, and we convert it into FileMaker query type operations. We're turning it into find request and omit operations and stuff like that. There's some extra logic in there to handle things that you can't do at all that way. Though, like write outer joins, I believe we don't do. There's some things that we don't actually support because it's just way too hard. We try to use our indexes, even if we can't convert it into a FileMaker style query. We do use the indexes that we have if we can use it for that type of request. And this works pretty well if you're just dealing with one table and you're not requesting data that requires a join going on. If the SQL request is all asking for one table, we'll just pull the data directly from the actual table that's inside FileMaker. If you're adding calculated columns or doing joins, FileMaker will actually have to create a temporary table that you can't see that exists just for the query operation, or as long as the cursor exists to walk up and back and forth on it, to actually store the results of the columns and operations. And that's when that really gets the slowest part. If you can keep your SQL queries to just dealing with one table, those should work pretty performant. It's when you go through and you start making FileMaker to do joins, so then it has to make a copy of the resulting tables, and it'll store that on the side. Now, people have asked, well, why can't I create temporary tables myself on side FileMaker? And that's a common request, and that's another one of those things that haven't made it over the line to go in. Okay, now I'm going to switch over to file maintenance and get off queries and stuff like that for a while. So I'm kind of starting off from this dialog here, the save a copy as. Because there's a lot of low-level internal stuff that goes on, and all these different choices actually do drastically different things. So we have that dialog we showed you have 4 choices. You have copy current file, compacted copy, clone, and self-contained copy. And then there's actually a bunch of other big operations too that I'm going to go to later. Copy a current file is the simplest. It's basically the same as what the server is doing for backup. And I believe it's actually the same exact code too that it does. It basically just picks up every block. We store FileMaker files or blocks of 4K is the actual contents. Everything is split up into these 4K blocks. And then as I mentioned, there's these 255-byte keys that point to fragments of what we call chunks that are inside there. So you have keys and chunks, and we fit as much inside one block as we can of those keys and chunks. But when we're doing file maintenance like that, we tend to be working with 4K blocks at the time. And when the Draco engine was designed, well, the first version of FileMaker actually did 512-byte blocks because that's how operating systems way back then worked. Talking to a floppy drive, you wanted to talk in 512K byte blocks and stuff like that. We bumped it up to 4K. We actually did a bunch of studies. We had versions that were doing 1K, 4K, and 8K, and 4K tended to work the best in the 90s. And with SSD drives now, we could probably maybe make the blocks bigger, but we don't want to change. This would be a major file format change if we went through and changed the block size. And with SSD, I'm pretty sure probably the block size really doesn't matter too much because things are so much quicker now doing that. But that is something we could go and look at and study. But when we come up to doing a new file format, maybe we'll study and look into that again, whether that'll actually be worth changing that size. The first one is pretty simple. But when you say compacting, I mentioned how we have these keys and chunks that are stored in blocks. So what compacting does is it'll try to squeeze as much of free space out. Because as the file's operating and you're putting in these keys and chunks into these blocks, we're removing things, we're putting things in. But when we remove things and stuff like that, there's still some free space available. Or if we want to put something in and it doesn't fit inside the block, we have to split the block into 2 blocks. And then you have free space in both sides. So over time, the blocks spread out and you have a bunch of little free space all over the place. What compacting does is goes through and will take the contents of A, merge as much of contents B as it can into one block, and then you have that first one. And it'll do the same thing with B, the remains of B, the contents of C, and so on to squeeze it down. It can take time. It can free a bunch of space depending on how often you're adding and deleting things inside a FileMaker file. Actually, if you never delete anything, probably still pretty compact at that point. But you have to remember that modifications, when you modify a field, is actually there's a delete operation and an add operation. So as things are coming and going inside of out of the indexes, and the blocks that contain the indexes will tend to get a lot more free space as things are coming and going in and out of those blocks very often. Once if you do a compact of a file, it will most likely speed up read operations because it doesn't have to read in as many 4K blocks, because we read in 4K blocks at a time. But write operations may actually be slower, because as I mentioned, as we start doing indexing, and I need to index my last name Mackle, and there's not enough space in the block because Mackle has to go at a specific location in there because it's stored in key order. If there's not enough room in there, I'll have to split the block, which is have to increase the size of the file, move half the contents of that block out over there, rehook up all the blocks back to each other. You'll see those linkages coming later. So that can actually slow things down quite a bit. I'm kind of showing that key structure that I'm talking about, where each of these dots is a key, and then there's data down at each of those locations. So on the left, that kind of represents the entire tree of data, layout, scripts, where it's all stored in a tree structure. And there's some links to some previous talks where we talk about that structure a bit more. But what a clone does is kind of just prunes the tree. It prunes all the nodes that have data in it. Actually, it's kind of opposite. It copies over all the nodes that don't have data in it. It's copying parts of the tree that it does need. And actually, that's pretty much how the migration tool works. The migration tool works at this level. It doesn't even know that it's moving records around. It's just moving parts of trees back and forth. As it's moving chunks out, then usually data will eat up a bunch of blocks, and at that point, those blocks will just be deleted. Self-contained is an option that came into existence when we added the remote containers. And that's basically, I don't know, does anyone ever use this feature? Okay, a few hands up there and stuff like that. You didn't know how many people were going to actually use this or needed to do this, but if you have all your containers and you're doing external storage, and you have all these folders underneath it with all these files. But then if you want to move that elsewhere or transmit it or pack it, or sometimes you want to push everything back into one file to make it easier to transmit, compress, maybe go into storage, long-term storage or backups or whatever reason. That's basically what it does. All it is basically as if you went into define fields and clicked the store local option on every field. You could do it by hand. You don't necessarily have to use this, but this is just kind of a quick way to suck everything back into the individual file. Now, those were the 4 options that were in the Save As dialog. Now, there's other big block manipulation things that are going on. Actually, just closing a file can cause a bunch of block manipulation occurring. Because as you're going along during the day and you're adding and deleting things, or actually if you go through and you delete quite a bit of stuff, you'll end up with a bunch of blocks that actually have no data in it at all. And FileMaker does not shrink a file while it's running, ever. As long as the file is open, a FileMaker file will never shrink in size. The only time that it does do that is when it's closed properly. If you crash, you won't get there, and talk about that a little bit more later. But at the point that you close it, FileMaker in memory is keeping track of all the blocks that have no data in it. And at that point, when you close the file, it'll just go through and say, okay, block B is empty. The block toward the end of the file that has data is G, so it'll copy the drive, the 4K at position G, and move it to where B was. And then it'll take, I have an empty spot at C, I'll take the data at E and put that there. So you kind of end up folding, so the blocks don't end up in any type of, if you did a save a compressed copy and then deleted a bunch of middle stuff, you'll end up with a file that's kind of ordered, logically going back out and then kind of looping back again, because we're flipping everything backwards, kind of like doing a reverse sort. And then once we have all the blocks containing data and no free blocks in the front part of it, then we actually tell the operating system to truncate the file and to free up that part of the disk space. Then we have consistency check. This is what server does. There's in the recovery option, when you recover, I think there's a couple different places where you can turn on to say do a consistency check. It's usually always triggered, well, you can trigger it manually and also when a file is closed, well, when a file is open, we don't do anything with it. But the first time you make a change, we delete a specific byte that's at the front of the file and then flush that out. So if the file gets closed, if you go through the closing process and we truncated the file where we removed all the free blocks, we put that byte back in, and then we know that the file was closed properly. When we open a file and we don't see that byte there, I forget which way, whether we put a byte or we remove it, but whichever way, if the state is wrong, we'll know that the file wasn't closed properly, and we'll go into this recovery consistency check. This diagram kind of shows how all the blocks are interrelated. So there's the first block is kind of our root block that contains, it actually has its own index. When I'm talking about indexes, I'm talking about block indexes. We have indexes in blocks that point to other blocks for what the first key that I'm talking about in this key structure, where that's located. So these are even lower level indexes than the ones I talked about earlier. So the root has an index pointing to yet other index pages, and these index pages point to other actual data pages. The number of index levels can go up to like 15 or something like that, but typically you never get over maybe 3 levels or something like that until you start getting into like maybe petabyte size files or something like that. I've never seen one past 10 yet, and I don't really want to see one past 10, I guess. So what the validation is doing is it's going across all these blocks, making sure the contents internally in a block looks consistent, because in the header of each block it says how much free space is in there, and if it goes through, or how much data is in there, and then if it doesn't match the amount of free space, it says this block looks completely trashed, or it'll walk through the block and say, the keys and, it just doesn't make sense inside of it, and it'll say that it's bad. It'll make sure that the linkages are correct before it, that all the index blocks point to index blocks, or either point to the index blocks or the data blocks that exist. And then even all the data blocks each data block is linked to the next data block and the previous data block. And so that's the consistency check. And then recovery, basically, once it does that consistency check, what it does is basically just, what the first 2 steps in recovery, you can actually skip that. There's a paper on, I'm going to point to about recovery. What recovery does is it basically only looks at the data blocks. It goes across the entire file just looking for pure data blocks. If it's one of these index blocks I talked about, it ignores it. If it's a data block that it can't make sense of consistency, it just ignores that one. If there's 2 blocks that overlap, if for some reason block D has a key that should really be in C or vice versa, it'll throw away D and just use C. So it's basically trying to truncate things down to just get valid blocks. Then it starts putting them together. It generates a new root. If there's a gap between, like B disappeared for some reason, and there's a gap in the key range between A and C, it'll create a little glue block and put that in there. And then it'll just start hooking everything up properly. It'll regenerate all the links properly. It'll regenerate all the index blocks that are needed. And then that's kind of the end of the whole block. At that point, we have what's called a valid HBAM file. And this new feature that they talked on Monday will basically get you back to that same state too. It's getting the valid HBAM file together. And then recovery has all this other stuff in here that does scanning indexes, rebuilds, container data checks, and stuff like that. So I have the links. This will be posted on the website, or it is a slightly different version of it is already up there. There will be an update for it. So there's a link to my talk from 2 years ago. There's demystifying the file recovery. We did a talk back in, I think, 2012, I think, on recovery and stuff like that. This talks about Pro 10, but pretty much everything in there is still relevant. How we walk through the blocks. I mean, there's some changes. Layouts now have themes in addition. So when it's talking about layouts, you have to realize it's doing the same type of work for themes and stuff like that. You have to kind of expand. But the general operations and what goes on and the policies and stuff like that are still good things. It's a good thing to read if you want to look at recovery. There's the link about which functions can't be evaluated on the server, and we'll force the queries to be done on the local host. John's talk from last year, he went into like a lot of the details of what the web publishing engine and the perform script on server, how those processes work. He talks more about the tree format and how we do locking and a bunch of other operations on the tree structure. And there's the link to his actual talk. And then I had space here, and then so I put links to all the last 4 DevCons. And it's really pretty interesting. I was going through and saying that, oh yeah, there's all these talks that are around there. I don't understand the scheme for the URLs. Like every year is different, but I was just trying to guess, well, okay, this is 2017, so I just need to change it to 16 and it should work. But no, we went from underscores to dashes and stuff like that. But okay, we have some time for questions. I guess we have 12 minutes left for questions, if there's any. Please come up to the microphones here so that they get recorded.
How come you can't cancel find when it's performed on the server, or when a hosted solution is?
Basically, the network protocol doesn't have a command to send a cancel operation to the server right now.
Okay, because even if the user force quits, you're still queued up. Other users are queued and waiting for that to complete, and they all appear hung.
Once the client gets disconnected, there is code in there to try to shut down any operation from that client that's going on.
Except the search.
Yeah, some of the search operations can take a while, especially if it's an unstored calc and stuff like that. But that's one of those other features that it's been on the list for a couple times and just keeps not making to it.
Caused a number of problems.
Right, yes.
All right, thanks.
Let me go one more on this side first. Yeah.
When saving a compacted copy, what's the behavior for external container data? So if I have a 20 gig data file that I want to compact and I have 100 gig of external container data, do I just get the compacted file of the data, or does anything happen with the containers as well?
No, the containers are pretty much completely ignored. The containers are stored as there's entries inside the records that point to the actual containers out there. But these manipulations, these block level manipulations I'm talking to are only dealing with the FileMaker file. All of the container data that's stored externally is completely ignored at that point.
Okay, thanks.
Yes, sir.
So when you said that you talked a little bit about when you close a file, what happens, right? Mm-hmm. When does that happen, and how does it happen on the server when it's hosted? Is it when you actually close the file and it's no longer available to users, or when the last person logs into, logs out of it? I mean,
yeah, that's kind of interesting. It has nothing to do when users are logging in or out. It's done at the point that actually the server closes a file when it's shutting down, or you go to the admin console and close it down. But yeah, I didn't realize. Yeah, just after asking that, I realized that it's also done when when a backup is performed, or if you tell the server to pause the file. So on server, when you pause a file, it puts a lockout and tries to get a lock on the entire file to stop people from making changes to it. But then the first thing it does after it gets the lock on the entire file and no one else can make a change to the file, it'll go through and start moving all the free blocks to the end and truncate it to put the file in a safe state so that you can go through and, while the file is paused, that's the only time you can really use some other file operating system commands to make a copy of a file that's actually opened by the database engine. But that is one other point where we actually do that operation, is on the server when you pause it or you actually close the file using the close command in the admin console.
If you import a large record set and you have indexes on, that's significantly slower than if you drop all the indexes, import the records, and rebuild the indexes. Could you talk about the mechanics of why that's so?
It's one of those things, it always kind of depends. But I was telling you how these different blocks can have a different amount of free space and stuff like that. So when you drop all the indexes, you've basically thrown away all these indexes that have been created that may be compact and compressed. When new blocks come in, we tend to add a little extra free space to them to make sure that when you're adding a lot of stuff that they can go, that we can find room to stick these nodes in as records and stuff like that are coming in. So that may be one reason why the indexes are a little bit faster, is because you're rebuilding it from scratch. And you'll probably see that the file size is probably ballooned in size quite a bit more than if you did the import with the indexes still there. If you probably do the import with deleting the indexes, import the data, and create the indexes, it'll probably be a lot larger file than if you did it just importing in place. And it's kind of hard to tell because it really depends on the state of how much free space you had in each of these different blocks and what happens. But I guess there's enough empirical data out there that I'm pretty sure that's what's happening at that point.
So in find mode, there are operators which are very helpful, like greater than, less than, and duplicate. I was always curious, why is there no unique?
I think we ran out of characters to pick. I mean, it is the operator can be done because it's being done by the field schema, forcing unique values and stuff like that. Yeah, it's just one of those. Actually, I don't know if I don't know, you've probably seen that on the list of feature requests and stuff like that, but.
You asked if people are using the save as self-contained copy. We definitely use that, so please don't take that out.
Oh, okay.
And on that topic, you mentioned that it's just the equivalent of going in and changing that checkbox and all the things. But what I've noticed is that when I save that, it also updates the modification timestamp on all records, which is kind of destructive if those are important.
But I think if you did it by hand, it would update the mod count.
Oh, would it? If
yeah.
you just changed it in the field definitions?
Yeah, because it's going through the standard query logic and stuff like that. But
what we've instructed our users to do in that case is to disable modification timestamps in all tables, then save the self-contained copy, then turn the modification timestamps back on. So that's not a great workaround.
Actually, I wonder if maybe we may be able to do something. We're having to change. If you saw in the stuff on Monday, we're changing the import and when things get triggered for auto updates, and we're getting a finer level control on fields and stuff like that. And as part of that work, we may be able to squeeze in something like that, because that's in the same exact area that we're touching now.
Thank you
for that part. But
I've had a few files in the past fail the consistency check, and I get a message that says, "Don't use it. Restore from a backup." How serious are you about that?
Just how often do you like going to Vegas, I guess, is the thing. It's, yeah, no, backup. The consistency check, I guess I'd really be worried if it fails that first part of the consistency check. If there's actual block damage that has occurred underneath there, a bunch of weird things can happen, and you don't know if it's really going to be hard to determine why it failed, because you saw that picture with all this linkages and these pointers pointing all over the place of these files. And if one of them is wrong, it may be if you're walking the cursor forward, it'll be able to find data. But when you start going back, why is it when I hit the back arrow in records, for some reason I never see record 3. But if I go forward, I do see record 3. And a reason for that would be because the consistency check failed because that linkage was not there. It somehow jumped from record 17 and went to record 2 or something like that. Behaviors like that will be hard to actually determine, and things may work perfectly fine as long as you never go backward. In that case, for that file, as long as you never hit the back arrow key and go backwards as looking through records, you'll never see the problem at all. But when the one time someone does that and it happens, and you say, "Why did that happen?" And they say, "Well, it must be something." I go forward, "Oh, there's the record. Everything must be fine. I didn't do something right." So that's the type of problems if the consistency check fails and stuff like that. Now, I'm not as strict as John was on when you run the recovery process. If the first 2 validations go through and there was no block damage, I'm roughly pretty confident in being able to use a recovered file at that point, though.
So during the recovery process, which can take sometimes hours, there's an option that says skip the rebuild index.
Mm-hmm.
I ended up using that because they needed to get online, but what repercussions did I create by skipping the index rebuild?
It's kind of like the same answer I gave you the first time. If there wasn't any block damage, if you look in the log and it didn't say that it had to delete some blocks, or it had, it had to add a glue block or something like that, the indexes will probably be fine. The thing is that sometimes we've had bugs in there where we misindex things too, and running the recover will rebuild all the indexes and guarantee that it's correct and stuff like that. It's all really a bunch of grayscales of stuff like that, but if you get a block damage, you really need to come back from a backup. If it's just something where it wasn't closed properly and you ran recover on it, I've done that before on systems that I wanted to get up and running quickly. It's just let the index go through there. It's really kind of hard to determine whether the index is wrong unless you do a find for every possible thing that's in the index.
Does the index get rebuilt outside of the recovery process?
Only if you, in that dialog I showed you with minimal and none and stuff like that, if you say none, close it, and then just leave the option to let it rebuild it again, that's the only time it gets fully rebuilt. Okay. So you can do it. Or you can go in through ODBC and tell it to drop the index and construct the index.
Got it. Thank you.
Okay, I guess I'm out of time now, so let me pack up stuff here and I'll stand down here and you come up and ask me some questions at that point. But, I guess there's a few others. And remember to fill out your evaluations and stuff like that. I mean, Rosemary actually reads all these things and it is very important to her, so thanks.